Alright guys, this is Northern Oklahoma College Algebra Math 1513. We're doing a combined lesson on 3-2 through 3-4. So this is find all the zeros of a polynomial part 2. Alright, here's a good quiz question. Use synthetic division to find all the zeros and the factors of the polynomial. That means find the x-intercepts and then rewrite the polynomial as multiplication. Now the first thing I'm going to notice is that I have an x cubed for my leading term. That tells me there's probably 3 zeros. Okay, so there's probably 3 x-intercepts, but we're going to find out later on that some of these might be complex roots or complex zeros, imaginary zeros. Now, what's an imaginary zero? Well, where it actually crosses the x-axis, that's real. Now, these guys that should have crossed the x-axis, if they'd gone up a little higher, that's how I think about it. If that hump had gone up a little bit higher, that relative maximum, if it had gone up a little bit higher, it would have crossed the x-axis and had a couple of real zeros, but it did not. So there's just complex or imaginary zeros there. They didn't quite get up to the x-axis and cross. So we call them complex or imaginary. So if it really, really crosses the x-axis, you have a real zero, or a real root, or a real x-intercept. If it doesn't quite make it there and doesn't quite cross, we call that imaginary, or a complex zero. So I think I have 3 roots. It's an x cubed graph. I'm looking at the x cubed, so I know it's going to look something like this. It's going to open down as it goes to the left and up as it goes to the right. And I think it's going to have 3 zeros here where it crosses the x-axis. We'll see. Now the first thing I'm going to do is factor out an x, because I noticed that all of those terms, those 3 terms, have an x in common. So let's factor that out. It'll make our calculations easier. So I pull out the x, and what I have left is x squared minus 2x minus 15. Now at this point I like to peek at the graphing calculator. I love the graphing calculator. I want you guys to use it. So if you don't have a graphing calculator, download a graphing calculator app on your iPhone or whatnot. Or get on the computer and just get on one of those free online graphing programs that I showed you earlier. So I'm going to put in my function, my x cubed minus 2x squared minus 15x, and I'm going to peek at the graph on my graphing calculator because it's going to save me some time. That graphing calculator is a tool. Let's use it. And I see that there appears to be zeros at -3, 0, and 5. So I'm going to test those zeros by using synthetic division. You guys all know how to do synthetic division now. Let's use synthetic division to test a zero. I'm going to test -3 using synthetic division on this part of the polynomial. I'm going to see if -3 is a root. I'm going to see if x plus 3, remember that was what it would look like, x plus 3. I want to see, is x plus 3 a factor? That's what I'm asking, okay? If it goes in evenly into that polynomial, if we do the synthetic division and it goes in evenly with a 0 remainder, we can say that x plus 3 is a factor and that -3 is a root. So let's test it. So I have my 1, my -2, and my -15 from my polynomial, and I'm going to test the root, the 0 of -3. I want to see if it goes in evenly. And it does. It has a 0 remainder. So now I know, yes, x plus 3 is a factor. So let's rewrite our polynomial as multiplication, as factors, as a product of its factors. All right, our polynomial p. We had that x out front. That was our first factor. Next, we just found out that x plus 3 goes in. We tested -3, the root -3. It went in with no remainder. That means that x plus 3 is a factor. What's my other factor? Well, it's what's left over. Look over here. What does that mean right there? Well, -5 is my constant, and 1 is my x. So that means I have an x minus 5 left over. I took the polynomial x squared minus 2x minus 15. I divided it by x plus 3, and what I got was x minus 5. So breaking the polynomial p of x down into its factors, it's x times x plus 3 times x minus 5. There's our answer. So we had to rewrite the polynomial as a product of its factors. We also had to find the zeros. Well, this one's easy. That's -3. That one's easy. That's 5. What is this one right here? Well, that's got to be 0. So I have zeros at 0, -3, and positive 5. And here's our graph. Down to the left, up to the right. It's an x cubed graph. Looks a little bit like that. How about this one? What do I know? I know it has 3 zeros, and I know it looks something like this because it's an x cubed graph. I noticed that there's an x term in all 3 of those terms, so I'm going to factor out that x. So why don't you guys pause the video and see if you can do this one by yourself. So I factor out my x. I take a peek at the graph on my graphing calculator, and it looks like maybe 0, maybe 2, and maybe 4 are my zeros. So I'm going to test those guys. I'm going to test 2. So I'm going to pull the 1 and negative 6 and 8 from my polynomial. I'm going to divide it by 2. And I've learned it has a 0 remainder, so that means yes, 2 is a 0. That's an x-intercept. It also means that x minus 2 is a factor. So far I have the x that was in front times the x minus 2, which I just found, times what's left over there, x minus 4. So we've written the polynomial as a product of its factors, and now we just need the zeros. So 0, 2, and 4 are my zeros. So there's my answer. We wrote the polynomial as a product of its factors, and we listed the zeros. And we know it's an x cubed graph, so it's going to look something like that.